So I'm Kiran Patel, as Lionel said. So I work at Elemental. I've been doing video stuff online for about 25 years, which I feel better counting it in Olympics rather than saying 25 years. Running at the BBC, then Elemental. So I've kind of been a customer of it, producing the streams, and then also providing the tools and the services to run that out. And also, as Lionel said, the talk could have been titled "How many acronyms make video more reliable?" And I actually missed one off the title, which is part of the presentation. But we know, we've got UHD, HDR, everything else, but these are ones that some of those are familiar. There's two that we kind of made up just to add more to the whole mix. But the key for this is, I think everyone here kind of understands, it's not a surprise for this audience, live streaming is getting bigger and bigger. More and more people are watching. We had the Super Bowl stuff this morning. Millions of concurrent viewers are watching. We've also got providers like Prime Video, Netflix, Peacock, putting some of their biggest events exclusively online. So the bar for making that video reliable when it's streamed has got much, much higher, which means it can't fail. So we also then have a concept of what's the uptime you're kind of targeting your infrastructure to be. So I've used this table a lot in presentations because I think it's interesting when people say we want to hit a certain target of how many nines you're going for and what that actually means from a acceptable downtime you're actually targeting. And the 5 nines tends to be the goal for most of our customers. They kind of sit in there thinking, right, if we can hit that, that's the acceptable limit, and that kind of equates to about a second in a day. Or over a course of a year, it's about 5 minutes. But even that, I think, is kind of interesting because if you asked anyone, if you asked the Fox team, would they have accepted 5 minutes during the Super Bowl and then it'd been fine for the rest of the year? No. So there's the other concept of these are kind of abstract. You're hitting a target to kind of make sure, because really the goal is to just not to be down at all. And then how much do you put the effort in? How much do you put complexity and cost into your infrastructure to try and hit those targets, understanding that those are going to be trade-offs that you're making? So how do we work out where do we get to? And this is, I think, a build-up of why a lot of live streaming infrastructure diagrams will start looking very similar when you start seeing all the different presentations. Because if you start with the very old school original model, you have a single encoder, and if you I've assigned, say, if that's 99% uptime for that, that's going to be your SLA for that availability. But most workflows don't look like that anymore. You have an encoder, you have a packager, you may be having a component transporting up. And if each one of those has 99%, your actual end-to-end uptime is going to be reduced because you're having to multiply it. So you end up with 97% uptime if you've got this kind of a model, which is actually reducing what your availability time wants to be. So the goal ideally then is say, right, let's develop a system that makes that initial SLA for the individual components higher. So if we say here we've got 3 nines for each of the components, you're still having to multiply them. So you end up with an end-to-end workflow that has, say, 99.7, but that's still not good enough. You say, well, our goal is to have it up to 5 nines. And this is where you get the familiar shape of most architecture diagrams if you see how people are doing live streaming, which is, let's double it. Let's add some redundancy. So you've got your 99.7, 99.7. We do the maths that figures that out, which is kind of 1 minus the multiplier of those. So you end up with actually 99.9991. So you've actually beaten it by a little bit. So you get your 5 nines of resiliency, or redundancy at least, for your SLA for your end-to-end. But if we end there, all you've done is add complexity and cost. Because I was trying to find a kind of inspiring quote, and I had to make one up, but I think this kind of sums up what I think is the end-to-end for this, which is redundancy without a practical plan for failover is basically an expensive way to fool yourself into thinking, I've hit my target, and you ending up with a potentially still a broken stream. So the goal should be to have that failover as seamless as possible, ideally in an automated way, so your audiences are not impacted by any failures that are going to have a potentially impact. So if you have that 1 second of downtime, you can actually benefit from the redundancy and make sure your audiences aren't seeing any issues. So we can start throwing in the acronyms now for what we've tried to apply to make sure that the failover in various scenarios starts working really well. So the first one is the familiar one, which isn't in the title. So this is the CMAF, which has been around a while for a kind of a distribution side. It got introduced to be a common media format that you could have within a packaging format and then still distribute that as HLS and still distribute that as Dash. But we've added that as an ingest format, so not we, as in the industry has, and that means that you've got some benefits when you're talking between encoders and packages. It kind of gives you some efficiency within the media ingest. It gives you the benefits of still the efficiency with being able to distribute HLS and Dash to the end customer. But we added another layer, which means that if you have timecode in the source of that video, we can deterministically synchronize that video across multiple pipelines. And I've been doing it, I can't remember when we started, it was back when I was at the BBC, trying to make sure we get timecode in the source of our content. Anyone building anything new, I would please advise, try and get timecode in the source. It makes life a lot easier when you're trying to do failover. We understand it's not always possible, but that should be, I think that should be the goal. And then that gives you this kind of eye chart of a diagram, which will look familiar, but it's now built out of the AWS components, which I'll try and step through. So as I said, the thought process being we put UTC timecode in the source video at the beginning of the chain. So when that reaches your encoding pipeline, the first stage is getting it into the cloud with Media Connect, and then Media Live can use that. So the line between the two chains there, it's not a communication path, it's just indicating that the epoch timecode can be used to synchronize where the segments will start being encoded. So the actual different regions don't need to know about each other in this scenario. And then the media package is receiving those streams. It can take in two outputs from Media Live and fail over between those, and also emit various rules. So when the output's going to a CDN, Media package has rules within it to say, if it's stale as a manifest, it can understand that our segments need to be 2 seconds long. The encoder somehow is not doing what it's supposed to. My manifest is now 6 seconds long. I'm going to emit a 404 to force a failover rather than serve that manifest because it's still there, but we know it's a live scenario that's out of date. So that gives us an end-to-end workflow. We've automated the failover. If any of the components within the pipeline fails, if CloudFront gets a 404, either because Media Package has omitted it, because it's no sense there's a problem upstream, or Media Package has a problem, then CloudFront will know to switch to the different region. So you've got redundancy and the automated failover. And because we've got the timecode in the video source, that failover can be pretty much seamless. Now, is that going to play, or do I have to hit a button? This should play. So we overlaid the region, and you can see it switched from Ohio to Portland, and the video keeps playing. It'll switch back again, and the timecode will run, but the video will keep playing. So behind the scenes, that was switching between two different regions, and the video just keeps playing smoothly. And that's great. It's saying a 404, there's a problem with the input, there's a problem with an instance, it's a hard failure. We can switch seamlessly between the two instances. But what if that failure isn't as black and white? What if it isn't a 404? What if it isn't a power failure or a region failure? So this is the second acronym. So we added a concept within Media Live, which is called a MQCS, or a Media Quality Confidence Score. And the reason it's a confidence score is because it's not necessarily saying that this video is bad quality. It's just adding a score based off of various rules and various markers that we are kind of adding more and more to put within that video. And then the idea is that it can compare two bits of video and select the better of the two. So if it is content that happens to have faded to black, the score may lower, but then both pipelines will have lowered the score, and there's no reason to fail over because that's what the video is supposed to look like. But if one of them has lost an input and the other one hasn't, it knows that the video is better on one pipeline. It can prefer that one to stream to. So this video is a capture of a demo, because I wasn't brave enough to try a live demo on the screen. And what you'll see is so you can pay attention before I hit play, we'll switch one of the pipelines to a black frame. The video will keep running, and you'll see the same effect on as you're looking at it, the right of the screen, which will show the same region switch. As Media Package compares the scores that Media Live is emitting, it will drop and switch region, or actually switch pipeline within Media Package, because it's happening within one region, to continue the video playing. So I'm switching the video and making it go black, so forcing an error within the Media Live pipeline at the top. The red at the bottom left corner is what will change. And you can see at the red, that's the scores that are, it's detecting that the scores are dropping. You'll see that go black, but you won't see the one on the right go black because it will switch to this separate pipeline. So the third acronym is CMSD. So we're collecting that data. So this one, again, should be familiar. So it's Common Media Server Data. So as Media Live lets Media Package know that what the scores are for every segment, Media Package can then embed that data in the CMSD for those segments. So every downstream system that receives that data also has that information, so it can make the similar decisions. And that's better for when we want to do cross-region failover between, so a CDN can make that decision. So this is a very similar diagram to the one I had before. Everything's the same, but we've added, Media Live is going to be still adding those scores. So it's analyzing the video, assigning every segment a score. Media Package is receiving that. If it needs to, it can make the failover within a region, but it can also embed that score into the segments under the CMSD headers, so then the CDNs can be looking at that data too. So the way CloudFront have implemented this, it doesn't have to retrieve the video from the alternate region. It just does a head check to check the score. And then it keeps a rolling number for what the scores are within the alternate region that it's checking. And if that score gets to a certain threshold over a certain period of time where there is a difference, and in the alternate region has a higher score, it will switch to it. So it's not as seamless as if it's in region, because it's not doing it per segment. It's taking a rolling average. But normally it does it within 10 seconds, depending on what the segment length is. So in this example I'll play next, it's going to be a similar example where I'll force a black frame or black video into one of the pipelines. You'll see the end result, which is what your viewers will be seeing, go black. But after a few seconds, without any human intervention, the player will just switch to the alternate region without anyone having to actually touch or change anything. That didn't hit play. So the green bar at the top is the score that CloudFront is seeing. So it will take an average across a period of time. So there it's dropping. So the output's going to go black. Viewers are now seeing black for a few seconds, but because the alternate region has a higher score, this is a video and I'm still nervous, it switches over. So that brings us to that last acronym, which was the kind of the concept as a whole. So that's MQAR. We've got Media-Quality Aware Resiliency. So it's checking the quality of the video across multiple pipelines. It's making a determination of which of the two redundant pipelines has the better quality video, and then making sure that the serving to your audience is always that better quality video of the two. For further information across this, we've got a couple of, I thought I had it, this isn't that version. For further information, if you come and find me, we've got, I think, Dan across there and Rachel sitting just behind. So we're kind of PMs that have been working across this because it works across multiple services. We can kind of help answer questions if you have any. And we've got a couple of blog posts, which I thought I'd put in here, but I haven't, so we can share those as well. Thank you.